Seventh grade, Chapter 10, Section 5, Select Inappropriate Display. So here we have a key concept. This is in your notes already, but I want to make sure that you can see it and that it's big enough for you. So here we have it in our video to talk about. So type of display and best used to do what? So a bar graph. It's best to use a bar graph to show the number of items in specific categories. A box plot, it's best to use when you're showing measures of variation for a set of data. It's also used for very large sets of data. So that's the two times that it's best to use that. A circle graph is used to compare parts of data to the whole, not one to the other, but compare parts to the whole. A double bar graph is whenever you have two sets of data that you need to put together to compare. A histogram is when you need to show the frequency of data and you want it divided into equal intervals. So a histogram is whenever you want to show the frequency of data. A line graph is when you want to show change over a period of time. Line graph, if you see time, go to line graph. Line plot is when you want to show the frequency of data with a number line. So it's not that a histogram and a line plot can be interchanged since they're both doing a frequency of data, but a histogram it's a little more appropriate when you want to put it in equal intervals, whereas a line plot, you don't necessarily need to have it in equal intervals, you just need to know where everything is. So our quick check here, construct a double box plot for the data in the table, then compare the heights of the LA Lakers to the heights of the New York Knicks. So the first thing we have to do is put them in order from least to greatest. So the first thing we have to do is get them in order from least to greatest. So I just went ahead and stopped the video and did that. Now we need to find the mean, the upper quartile, and the lower quartile. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 numbers here. So we need to find the number in the middle. So cut it in half. That's 7 on one side, 2, 3, 4, 5, 6, 7. 7 on the other half, 1, 2, 3, 4, 5, 6, 7. So here is 81. That's our median. So for LA, we have a median of 81. We're going to need a lower quartile and an upper quartile. The same thing for New York here in a minute. So then we need to find the lower quartile. So that just means find the median here. So that's 79. The upper quartile, 3 and 3, so that's 84. And then for New York, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So here in the middle between 78 and 80 is 79. Lower quartile, 3 and 3, so 74. And then 3 and 3, so 82. Okay. So our double box plot, we need to have the lowest number of 69, the highest number of 85. So let's see. 69 here. We'll do 71. See if I have enough room. Let's see. Oopsies. Oh, goodness. Okay, moved it, got all my numbers on there. So we start with New York. So that's at 69. Well, I mean LA. We'll start with LA, sorry. 73 is our lowest number. Come up here and put a dot. And then our next number is 79. Our next number is 81. Then 84. And our big number here is 84. Not often you have your largest number and your upper quartile being the same thing. Then we need to go to New York, so our lowest number is 69. And then our next number is 74. Okay, hold on. Our next number is 79 on that. Okay. This should be at 79. Interesting. Okay. Now I'm getting it right. So 74 and then 79 and 82. And then our largest number is 85. So I can make our box and whisker plot here. Our median in the middle. Okay. And now compare the heights of the LA Lakers to the heights of the New York Knicks. So this was New York, this was LA. We can say that New York has a greater range in height, and we can say that LA is more consistent in height. Overall, I would say that the LA Lakers are taller on average. Let's see what they say exactly. The Lakers players are taller on average than the Knicks players. Yep, and you can see what they have here as well. Oh no, I had that right. 73 was the lowest. What am I thinking? Go back to this. I was right. The 73 was the lowest. I just wanted to think that I was wrong. Okay. At least I started out right. Shouldn't have second guessed myself, right? Okay, so 2. Candace used a double dot box plot to compare the monthly amount of babysitting money she brought home the last 2 years. So we have the top one is this year, the bottom one is last year. How many dollars more was this year's median amount of babysitting compared to last year's? How many dollars more was this year's median? So the median is right here for this year compared to last year's. Here was the median here, so that's about 95. And this looks to be about 110. So it's a difference of $15 between the two medians. Yay. How do you know which type of graph to use when displaying data? Well, to determine appropriate display for a real-world situation, we're going to learn that today. So this is the key concept that we went over. Remember to go back to it today. So select an appropriate display to show the number of boys of different age ranges that participate in athletics. Since the display will show an interval, a histogram like the one below would be an appropriate display to represent the data. So select an appropriate display to show the number of boys of different age ranges that participate in athletics. Okay, yep, histogram, so you can do different age ranges. You can say exactly how many there are. But yes, because you are trying to figure out exactly how many there are, showing frequency here, remember, you could do a line plot or a histogram, but when you want to put something into equal intervals, a histogram is best. If you want the total number, because you only have a few numbers, use a line plot. But as you can see, we will probably have a lot of people in these, okay? So in instance, we have 55, 70 students here in this, and that would be a really big number line. Okay, so let's select an appropriate display to compare the percents of students in the 7th grade who traveled to school this morning by bus, by car, or by foot. So one of the important things here is the percent of students in 7th grade who traveled by bus, by car, by foot. So if we go back here, a percent is a part out of a whole. Okay, so that tells me that the best thing to use would be the circle graph because it compares parts of the data to the whole. So I'm going to say circle graph. Select an appropriate type of display to compare the percent of ethanol production by state. Justify your reasoning. Then construct the display. What can you conclude from the display? So you're asked to compare parts of a whole. A circle graph would be an appropriate display because we're talking about Iowa, Nebraska. We have some really big numbers in here. If we're comparing them to a whole, we can put everything together and see it in one circle, and then we can compare and get information out of it by finding the percent out of total. Circle graph would be an appropriate display. Indiana, Minnesota, and Illinois produce about the same amount of ethanol because their pie shapes are about the same, 8%, 8%, 8%. Okay? I'm just going to leave the answer in this next one. Select an appropriate display to compare the percent of girls. So remember that percent of girls again, we talked about that just a minute ago. It's really good to do a circle graph here. The percent of girls who play in a soccer league by age range, the round percents to the nearest whole percent if necessary. Justify your reasoning, then construct the display. What can you conclude from this display? So to find our circle graph, because it is asking us to do the percent, first we have to find the total of 79, and we need to find what percent each one of these are. So 10 plus 29 plus 22 plus 15 is 79. To find percent, we take 10 and divide it by 79. We get 0.1315, so I round that to 13%. I take 29 divided by 79, and I get 37%. I take 22 divided by 79, and I get 29%. I take 15 divided by 79, and I get 19%. Okay, so 19 plus 29 plus 37 plus 13 is 98. And sometimes it's just because of how you round, like 13.1 went to 13%. Let me see, 22 divided by 79 again, because that's the one that they have different. They took it up to 29%. Yeah, and then 15 divided by 79, they said is 19%, which they took up to 20%. I mean, so they're going to be a little different. It's fine. Okay. And you can do approximate here. There is a method to finding the angle in the middle of your circle graph, but you have an idea of what it should kind of look like. 37 should be the biggest one. 29 is right behind it. Then 19 is a little smaller, and then 13 is smaller than that. So a circle graph would be an appropriate way to compare the percents to the total number of girls in the soccer league. And about 38% of the girls are age 9 to 11. Okay, I have 37%. Mine's a little more accurate. They were just trying to get 100 out of this. I'm not sure why they did it that way. That's okay. Whatever. So how do you know which type of graph to use when displaying data? Well, you go back to that chart I gave you. When you know the type of data given and how it will be analyzed, you can determine which type of graph to use.